Hi everyone. So let's move on to creating a MATLAB code that we can use for k-means moving average filter. As I said earlier, here we have a wave file called noisy.wave. It has an inbuilt noise in that signal. We would be using the k-means moving average filter to get rid of that noise. So this is the MATLAB code. So let's play the noise. Uh, so I have it saved over here. So let's play it.
Author of The Danger Trail, Philip Steele, etc.
Now you could hear very clearly this signal has an inbuilt noise. So now how are we supposed to get rid of that noise? By using K-means averaging filter. So this is a standard procedure. Always start your MATLAB code with close all, clear all, and CLC. That would help you to make sure that it's always starting with a fresh start. That's a standard procedure. Now, the next step is you want to read that signal file, right? As I showed you earlier, the main source file is labeled as noisy.wave. If you want to read a signal file, you have to use the command audio read. What it's doing is it's reading the signal and is trying to get the signal values as well as the sampling frequencies. You would see over here, this is the signals that you're getting and the sampling frequency is 48,000 in our case. Now, the next is the value of k is what we would have to constantly keep on changing to see which value of k would help us get rid of the signal. So let's start with a smaller value. Instead of 100, let's start with just 10, for instance. Okay, so that would be the averaging value of k that you're using. So let's start with a smaller value and then we'll progress accordingly. And then you're applying that filter, applying the moving average filter. So this is the command that you have to use, MOV, mean. You're getting the signal as you have taken it from here and the value of k that you chose over here. And now you're saving it under filtered signal. This is your filtered signal. You would see that the size is same. The values of the size is the same. All you're doing is you're applying a filter to get rid of the noise. Now, once you got rid of the noise, you want to save it into a different output file. So let's call it filtered output wave. So this is the output signal. This is the filtered signal that you want with the sampling frequency fs, and you're trying to store it over here. And that's why you're using the command audio write. It helps you to write. The read helps you to read, and this audio write helps you to write. Now you have to plot the signal. You want to see whether or not you're being able to get rid of the signal. So this is the length of, this is the time scale you have. And then you're plotting first the noisy signal, the original noisy signal. And it has the signal S, as you could see over here. This is S as in the noisy signal. And when you want to get a filtered signal, you'll use the word filtered signal. You're using the time scale is the same. And now you're using filtered signal to get the filtered signal. Let's run it. Let's save it and let's run it. Now you would see the original signal. You would see it's kind of noisy over here, right? And whereas the filtered signal looks more clean. But let's listen to the output signal as well. So as I said, I try to save it as the filtered output signal. So let's copy this. And this was the previous one that I was playing with. So let's paste it over here and let's listen to it.
Author of The Danger Trail, Philip Steele, etc.
Now you would see that the noise has reduced, but it's not completely gone. How about we use a different value of k? Let's use 50, for instance. And let's get rid of that previous file over here. Now let's play it again. Let's get rid of this one. Let's save it and let's run it. Now you would see it looks much better than the previous k-means averaging when we were using just 10. So now this is in terms of graph, but let's listen to it as well. So let us copy the signal again. Let's paste it over here.
Author of The Danger Trail, Philip Steele, etc.
Excuse me. So now what you would see is this signal sounds a lot better when we're using a higher value of k. Let's use 100 for instance. Let's save it and let's run it. It looks a lot better, but let's listen to the audio signal as well. So let's copy this one. Let's get rid of
Author of The Danger Trail, Philip Steele.
Let's get rid of this one.
Author of The Danger Trail, Philip Steele, etc.
Now you could hear no noise. I'm playing it again.
Author of The Danger Trail, Philip Steele, etc.
No noise at all. So now you see we've had an original signal. Let me play you the original signal again.
Author of The Danger Trail, Philip Steele, etc.
And let me play you the filtered signal.
Author of The Danger Trail, Philip Steele, etc.
So you were completely able to suppress the noise by using this MATLAB code. So by using k-means averaging filter, we can simply get rid of the noise. We have to just adjust the value of k at different values to make sure that the noise is completely gone.